what we have done in the last lecture, I want to expand a little bit on that, about making up solutions. This is the most important thing that you will ever do as a bioscientist. And that is a skill that, whether you like it or not, you have to learn. You don't even have to think about it anymore. After a while, you just do it instinctively. At the beginning, absolutely daunting, I know. I've seen some of the submission, and that was by far the hardest test that some people did. So I thought it might be a useful thing to talk about these things. And just a recap on the last lecture. What we discussed in the last lecture was the concept of mole. And I told you mole is nothing else but a certain amount of something. We discussed that 1 mole is the equivalent of 6.022 times 10 to the 23 molecules or atoms or entities, whatever you want to call it. We learned how we can convert mole into grams. So mole into grams. And we said what we need to do is simply multiply the number of moles that we have with the molecular mass of a substance. Yeah? Or if we want to convert grams into moles, we divide by the molecular mass. And I hope I have done the arrows the right way around. We also then started to play around a little bit with concentration, and we said concentration is defined as the amount of something, oh, it goes downhill, divided by a volume. So I could easily, for example, say what is the concentration of students here. So I would count the amount of students. It should be 231. I doubt that a little bit, but you know. And the volume is probably 500 cubic meters. So it would be, say, 200 students per 500 cubic meters. That is 0.4 student per cubic meter, roughly, don't know. But that is a concentration, okay? So these are fairly straightforward concepts. And what I want to do now is give you a little bit of practice. Here's, for example, not a very uncommon question. I have a substance, and this substance has a molecular mass, and I write it mm, molecular mass of 12,400 gram per mole. So 1 mole of this thing would weigh 12,400 grams. Or if I have 12,400 grams, I know it's 1 mole. And what I want to do is, I want to make up 10 milliliter of 1 micromolar solution. And usually this is abbreviated as M, capital M. And this M just simply stands for mole per liter. So capital M stands for mole per liter. Chemists, bioscientists, and all these people are terribly, terribly, terribly lazy people. So they come up with abbreviations. This M doesn't mean meter. So please don't write it as a lower or not capital M, because that could then mean milli or meter. Write it as a capital M. So whenever you see a capital M, it means mole per liter. So that is my task here. I want to make up this solution for an experiment or something like that. And I'm going to show you two different ways how it's done. So, task is clear. Find out how many grams of this substance, or I should say, how many grams do I need to weigh in? How many grams do I need to make these 10 milliliters of a 1 micromolar solution? And that is one of the tasks that you are going to do in one of the next practicals. That you make up a solution with a certain concentration, so that's our concentration here because it is an amount per volume. We want to have a certain volume of that, and you are given the molecular mass. This is so standard that you will use that, or you will do something like that for the rest of your life. Unless you decide to become a taxi driver, then you won't do that, because usually taxi drivers don't calculate in moles. But that's a different story. Okay, so how are we going to do that? So I show you two different approaches. The first approach, and if you want to follow this approach, I want you to remember a little phrase. Gee whiz. It's all about mole. Whenever you deal with something like that, you have to convert everything into moles. Yeah? So it's all about mole. Rhymes. Can remember it. So the first step in this case is, and this is a two-step procedure. We want to have 10 milliliter of a 1 micromole per liter solution. How many mole are in this solution? So that's the first question. How many mole do we have? Or do we need? That's the first question. And when we have the amount of mole that we need, we need to convert the mole then into grams. Okay, happy with that? So first we calculate how many mole we need, and then we calculate how many grams this would be. And we know the approaches for both, because we know that concentration is amount per volume. That would be the equation for the first part, to find out how many moles we have. And then, so that would be for A, and then we can convert the moles into grams. This would be step B. Yeah? Does that make sense to you? So in a way, we have the tools. Let's see if we can apply them. So, I better start with another page. A, how many moles? And we said we have 10 milliliter and a 1 micromolar, which is the same as mole per liter solution. Now, we said that is our concentration here. That's our volume. So we said concentration equals amount per volume. We are looking now for the moles, for the amount, this guy here. What do we do in order to rearrange this equation? We bring the volume to the other side. Yeah? So we multiply both sides with volume. I'll just do it slowly in this case. We multiply both sides with volume. What we get then is, what we then get is volume times concentration equals amount times volume divided by volume. And you see the volume cancels out, and we have on the right-hand side just amount. That was very, that was for people who find rearranging equations tricky. That's why I gave you this test on solving equations, basically. So what we have here is now volume times concentration, and that gives us the amount. So what is our volume? And my advice would be always, always, always do it in the base units. So the base unit of volume is liters. We know that we have a milli here, so we have the volume as 10 times 10 to the minus 3. That is this milliliter. Yeah? That's the volume times the concentration, and that is 1 micromole per liter. 1 times, what is micro? Loud? 10 to the minus 6 mole per liter. Yeah? And actually you see quite nicely the liters cancel out, so what we have got left is mole. So 10 times 10 to the minus 3, I can also write this as 1 times 10 to the minus 2 times 1 times 10 to the minus 6 mole. And that gives me exactly, thank you, that gives me 1 times 10 to the minus 8 mole. Yeah? Happy with that? So this is what I need. 1 times 10 to the minus 8 mole for this solution. So, let's go to step B. Step B was, I have to convert the mole into grams. Mole into grams. And we said we can do that by, if you remember, mole into gram, by multiplying with the molecular mass. So, I have 1 times 10 to the minus 8 mole times, and the molecular mass was 12,400, I think? 12,400 gram per mole. Yeah? Interestingly enough, you see what happens. The moles cancel out. What have I got left? Grams. Hey, this is exactly what I wanted, isn't it? So, I have to multiply 1 times 10 to the minus 8 times 12,400, and that gives me, what's that? Sorry? Thank you. 1.24 times 10 to the minus 4 grams. Exactly. So that is the amount in grams that I would need of this substance to make 10 milliliter of this particular concentration. So step A was convert into mole. Find out how many moles we need. Step B was convert the mole into grams. Yeah? Happy with that? You just have to sort of remember these steps. Now, let me introduce you to the second method that you could use. So we said we want to make 10 milliliter of 1 micromolar, I write it as mole per liter, substance with a molecular mass of 12,400 gram per mole. This is what we said. The second method is slightly shorter. It uses what I showed you before. It uses dimensional analysis. So how many grams? How many grams do we need for that? What is the unit of the thing that I'm looking for? It's grams. So let's write down grams. Do we have anywhere something in our given that has grams in it? Yeah? Where is that? Sorry? It is the molecular mass. Exactly. So we have 12,400 gram per mole. I have grams sitting on top of the fraction line, so that's good. Excellent. Yes. Woohoo. But I have got the pesky mole. So I want to cancel that out. Do I have somewhere anything that has mole in it? It's in the concentration, exactly. It is 1 times, I've got the micro, so be aware of that, 1 times 10 to the minus 6 mole per liter. What happens to the mole? They cancel out. So I have now gram per liter sitting there. Gram is still great, but the liter I need to get rid of. Do we have something with liters in it? Yes, we've got 10 milliliters. So that would be times 10 to the minus 3 liter. This 10 to the minus 3, that's the milli. What happens to the liters? They cancel out. What's left? Grams. Hey, I got my unit. The grams that I was looking for. I can stop now. So all I need to do now is write down 12,400 grams times 1 times 10 to the minus 6 times 10 to the minus 3. I just hack that into my calculator, and I get 1.24 times 10 to the minus 4 gram. Which is exactly the result that I got with the other method. But this one here is much quicker. Does that make sense? This dimensional analysis. In the first method, I did this two-step approach. First convert everything into mole, and then convert the mole into grams. This is sort of, if you like, the rational approach. This is like it's almost like cooking pasta the proper way. Or you just can microwave it. That's this dirty trick with the dimensional analysis. For this dimensional analysis, you don't need to remember any equations. You are just guided by the units of things. Does that make sense? Yeah? So what you need now is a little bit of practice in doing these things, and that is why we have this little quiz about the making up solutions. One thing that you might encounter sometimes, though, when we talk about concentrations, is something really weird. I told you concentration is always given as amount per volume. So it would be mole per liter. That's the base unit for concentration. What about, could we have gram per liter as a concentration? Would that be a legal concentration? What do you reckon? Yeah? Yannis says yes. I fully agree with him. It is a legal concentration. It is gram. It's a mass, but it's also an amount per volume. How about the following? What about 1 gram per 100 milliliter? Would that be a concentration? He goes, yeah, so I have no reason not to trust you, so it is a legal concentration. How about if I know, for example, that my 100 milliliters, if I know that these 100 milliliters weigh exactly 100 grams, so that is, for example, the case in what substance? Loud? Water, exactly. Yes, so that is the case for water. 100 milliliters are exactly 100 grams. Now, could I just a sort of a little bit of a crazy idea. Could I replace this information, this 100 milliliter, could I replace that actually with 1 gram per 100 gram of water? Could I do that? Because everybody knows that 100 grams of water is the equivalent of 100 milliliters. So, in theory, I could do that. Yeah? Are you happy with that? I could do 1 gram in 100 gram of water. Or I could do 1 and cancel the grams out. 1 in 100. Any objections? Okay, I carry on. What is 1 in 100? Give me another word for that. Yeah, 0.01. What else? 1%. Exactly. So this would be 1%. Yeah? This is 1%. And I probably should tell people what I mean by that. I mean gram, and that is a weight, and the 100 gram, that was just sort of a trick to substitute things. That would be a volume. And I indicate that with 1% weight per volume. With the implication that this volume is water, where 1 gram weighs 1 milliliter, or 100 gram are 100 milliliter. Yeah? Does that make sense? So, a 1% solution, weight per volume, means 1 gram per 100 milliliter. Okay? That is something that I want you to remember, because very often you will come across that. 1 gram per 100 milliliter. We will find that occasionally as a concentration. And of course we can convert this gram we can convert that into mole again. So we can interconvert gram per 100 milliliter into mole per 100 milliliter. And if we take that by 10, we get it per liter. Yeah? From 100 milliliter times 10, we get this into 1,000 milliliter into liter. That makes sense? Very quick. Can you do me a huge favor, all of you? Can you quickly stand up for a moment? What on earth is he doing, huh? Now you can sit down again. I just wanted to get the blood going a little bit. Thank you. One more thing. It's a little bit like an Apple presentation. We've got one more thing for you. And this thing is, I just showed you how we can make up solutions when we have a substance, let's say as a powder, that we can easily weigh in. But sometimes somebody has done that already. And sometimes they have already made what is called a stock solution. So, for example, if you go to the supermarket, you have the choice of buying fresh oranges and squeeze your own orange juice. It's very healthy, I've heard. You also have the option of buying these highly concentrated, squash thingies, which you have to dilute. because otherwise, it gives you hairs on your chest. This stuff is so horrible that, it's not a good thing. So somebody has already taken some artificial oranges and squeezed them and made this stock solution, but you have to dilute this solution before you can even go near it. Even my cat refuses to drink that, and that's, that says something. So sometimes we work already with stock solutions. And we want to make stock solutions into what is called a working solution. This is basically the stuff that you can drink. And let's see how we can do that. It boils down to it's all about the mole. Let's say I have a 0.2 mole per liter stock. And I want to make 100 milliliters of a 2 millimolar working solution. So that's my squash. That's the stuff that I can drink. What do I need to do? The way we can deal with that is, remember, it's all about the mole, exactly. So we can actually say, let's calculate how many mole we actually need for this guy here. Yeah? And I said, we can use this equation. Concentration equals mole per liter, or volume. And in order to get the volume, we bring that over. So we have volume times concentration equals mole. So we have 100 milliliter, that's 100 times 10 to the minus 3 liter, times 2 times 10 to the minus 3 mole per liter. Yeah? Happy with that? It's just simply applying concentration equals amount per volume. So that gives me, what does that give me? 10 to the minus 6, 200. What's that? 2 times 10 to the minus 4 mole. Is that right? Have I done that right? Yeah? So I need 2 times 10 to the minus 4 mole. And I need to take that from this solution. I need to take this from my stock solution here. How do I do that? Well, again, we have concentration equals mole per volume. And now I need to find out how much of the volume, how much of my stock I need to take, of this liquid I need to take. So I'm now looking for the volume that I need to take. So I bring that to that side and the C, the concentration, to that side, and I've got volume equals the mole that I want, that is this here, divided by my concentration of the stock, that's this one here. That's this guy here. So I've got volume equals 2 times 10 to the minus 4 mole, that's the stuff that I just calculated, that is how much I want, divided by 0.2 mole per liter. Yeah? Because that is my concentration here. Let me write this onto a new page. Volume equals 2 times 10 to the minus 4 mole divided by 0.2 mole per liter. The moles cancel out and the liter go up there. So we have, what do I get if I do that? I get 0.001 liter when I do this calculation. Yeah? And I can convert that, if we do the metric conversion, 1 to 3. This is 1 times 10 to the minus 3 liter. And that would be 1 milliliter. So, what I need to do is, in order to make these 100 milliliter, what do I need to do? I need to take 1 milliliter of stock solution and how many milliliters of, say, water? Loud? 99. Be careful. It's not 100. It's 99. Because my total volume should be 100. Yeah? This is, for some of you have done that calculation, this equation. This is this famous equation where it says C1 V1. Have you heard about that? Yeah? C1 V1 equals C2 V2. Yeah? Remember, concentration times volume, that is mole. That's the amount. So that's the mole, that's the amount of mole in the working solution. And that is also the amount of mole that we take out of the stock. That is this famous C1 V1 equals C2 V2. Does that make sense? Again, you need some practice. That was one way. Now, I've discovered that my brain works in a slightly different way. I told you, I don't do complicated equations. C1 V1 equals C2 V2. I never can remember who is what. And when I have to make up these working solutions, I imagine a guy coming into a pharmacy. No, looks like a dollar sign. Pharmacy. No. So this guy goes into a pharmacy, and in his hand, he is holding a prescription. At my age, it's not very uncommon to have this scenario. And on this prescription, the doctor wrote, give this patient 100 milliliter of a 2 millimolar solution. This is the working solution. That is what the patient has to take. And the patient gives that to the pharmacist, and here is the desk or the counter. Here's the pharmacist. That should be a nurse hat, but my drawing abilities are rather limited. But the nurse or the pharmacist says, "I'm terribly sorry, we only have a 0.2 molar stock solution." So what you have here on top is doctor times doctor. That's what the doctor wants. And that is what the nurse has. So for me, it's doctor, doctor. And look at this nice counter here. This looks like a fraction, doesn't it? Doctor, doctor divided by nurse. That is what you sometimes hear me saying. This is the working solution divided by what I have as the stock solution. So, working, doctor, times, that's the working volume, times working concentration. That's the other doctor, divided by what the nurse has, that's the stock, that's the nurse. And, it helps me to imagine that, because I don't have to, again, remember any horrible equations. And I actually love doing these calculations because when I was back in Germany, I'd love to go to the dentist. Yeah, exactly. What? People said, are you... The reason was that the nurse at the dentist... Bloody hell, she was hot. Wow. Whenever somebody says nurse, it goes like... At one point, I was so distracted that the dentist asked me whether I want an injection, a painkiller, and I was completely on a different level because the nurse was there, and she was bending over me, and I forgot to say, yes, I want an injection, so he did everything without injection. Oh, bloody hell. But it was worth it, I tell you. So whenever I think about what the nurse does in these calculations, I have a smile on my face. So I go doctor, doctor, divided by nurse. Working solution, divided by the nurse. I hope you have lovely encounters with some of these equations. And you enjoy them as much as I do. Don't forget to submit your numeracy tests by Friday, 5 o'clock. See you on Monday.